The price to send a large envelope first class mail is 88 cents for the first ounce, 77 cents for each additional ounce. The table below shows the cost for weights up to 5 ounces. And they cited this source, so this was real postage costs. How much did a large envelope weigh that cost $2.07 to send? Well, it would be helpful to have an equation. So it doesn't tell you to write an equation, but an equation would be helpful. Or you could extend the table, right? Keep going until you see $2.07 pop up. Let's do both. Let's see if the equation works as good as extending the pattern. So take a look and figure out how much it's going up by. One way to do that is just to subtract. You could just do $1.05, take away 88 cents. And it actually tells you in the word problem, but I'm taking it step by step with you. $0.17 for each additional weight. All right, so I plugged in the first amount. I plugged in the common difference. Now I'm going to rewrite all of this to have an equation. And the computers at the post office are literally just using this equation. They put their envelope on the scale. This is programmed in their computer. The price pops up, and that's how much the worker says that the customer owes. You guys got 71 here? Anybody? Thank you. So here's our equation. The problem did not say to write an equation. It says to figure out how much did it weigh if the cost was $2.07. So the cost is the output and the weight is the input. So I'm going to put $2.07 on this side of the equal sign. And what we're solving for is the weight. So what's unknown is how many ounces it is. What was known was the cost. What was unknown was the ounces. So put your line in and solve your equation. And we'll answer in a complete sentence. I know it's a lot to fit in. Oh, you're on your notebook, so that's good. The envelope will weigh 8 ounces. Now, I'd like to test our equation by just adding 17 cents and continuing my table. So. You know, if I just follow the pattern, I should see this cost of 207. So this would be $1.73. This would be $1.90. And there it is, 207. So we could have just followed the pattern out, but using the equation is best because then you can use it for anything. Any questions on number 1, word problem? Number 2. Wanda is the manager for the soccer team. One of her duties is to hand out cups of water at practice. Each cup of water is 4 ounces. She begins practice with a 128-ounce cooler of water. How much water is remaining after she hands out the 14th cup? Maybe it would help us to make a table. You know, think about what tools might help you. You don't have to make a table. Feel free to work on this at your own. You know, problem solve and critical think what's going to help you solve it. I'm going to show it by starting with a table. All right, when I've given 0 cups away, there's 128 ounces. I've given 1 cup out. Each cup is 4 ounces. So I'll have 124 left. After 2 cups, I'm down to 120. After 3 cups, I'm down to 116. Every cup that the manager pours out is 4 ounces. So it's going down 4 every time. Now, how much water is remaining after the 14th cup? We could just keep subtracting, right? Let's write an equation. If you want to keep subtracting, you go right ahead. I'm going to write the equation and you can check. If you want to continue the table until you got 14 here, you do that and you can check the answer I get with my equation. Okay? So I put the first value in here, not the 0, the first one. After 1 cup, I had 124 ounces. This is the equation that will model how much water is left in my water cooler. How much water is remaining after the 14th cup? That means I'm going to find A with a little 14. So 172. Did anybody make the table longer? No? You did? Did anybody make the table long and get 72 when you got to 14? Oh, you did it? So write your answer in a complete sentence. After 14 cups, 72 ounces remain. So pretty much each player can have 2 cups of water. That's gonna be enough. Should we bring in another jug? Maybe, yeah, maybe if we're gonna be out there for 2 hours, maybe we have 2 jugs. So each player can have 4 cups of water. Right? Maybe 4 jugs. Maybe just a jug per player if you're playing in Florida. Take a shower. Okay. Alright, go ahead and try number 3 on your own, guys. Try to write an equation on number 3. This shows how many water was given out. The n term means like you're writing the equation in a box here with the n and the n. Oh, okay. Instead of having a number.
Oh, yeah, I know. I do that.
No, someone means it's going to add to every row. Someone means continuous pattern. Great reason why we're probably and so on. This theater seating is the one I usually put on the test. Some version of this. So our first row is 20 seats. Every row goes up by 2. Rewrite your equation. And the equation that shows the seats would be an equals 2n plus 18. And if you're wondering how many are in the last row, you'll plug 25 in. It says there's 25 rows total. It'll be 50 plus 18. There will be 68. There will be 68 seats in the last row. So there's a whole nother formula. It's called a series. If you go from a sequence to a series formula will actually add all of the seats up in all of the rows. So when you move on into Algebra 2, you see it in ACE Math, they give you another formula. It's called an arithmetic series, and they say, okay, there's 25 rows. It's going up to every time. How many total seats are in the auditorium? instead of just how many are in each row. So it adds them up for you. Yes. Okay. Yeah, if you've gone on to number 4, the numbers don't go up by a consistent amount, so that's a no. Number 4 is a no. That's not an arithmetic sequence because there's no constant difference. Time to go. Okay. I guess we don't have time for number 5. So please pass those papers up. I'm going to use them next period. You do have homework. Do your homework. And tomorrow we'll start reviewing for your test next week. Please pass those papers forward.